Okay, calculus. I'm going to go over some actual free response questions. I want you to read them, see if you can set them up, and then stop this when you get to a point where you can try some by yourself, and then turn it back on if you need help. Okay, you have to start taking some responsibility for your own learning and seeing if you can figure out how to do some of these. All right, so this is 2013 free response questions. We're not going to do all of them, but we're going to do some of them. So let's start with question 1. On a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of T, where T is measured in hours between 0 and 8. At the beginning of the workday, the plant has 500 tons of unprocessed gravel. During the hours of operation, from 0 to 8, the plant processes gravel at a constant rate of 100 tons per hour. So let's just think of what those things mean for a minute. Okay? G of T is the gravel is arriving, coming in. Okay, that's the rate at which it's coming in. And then it's going out at a constant rate of 100. Okay. So this G of T is measured in tons per hour, and 100 is 100 tons per hour. So those are the same. And we're starting at T equals 0. There is 500 tons. So before anything is coming in or going out, we're starting with 500 tons. So let's see what they're asking us. Part A. Find G prime of 5. Use correct units, interpret your answer in the context of the problem. This is super easy. Don't make it harder than it is. Okay, super easy. This is a calculator problem. You're going to be able to use a calculator. All you have to do is say G of 5 equals negative 24.588 or 587, depending on how you're rounding on your calculator. You're just putting G of T, which they gave you there, as 90 plus 45 cosine T squared over 18. You're putting it in your calculator and finding the derivative of G at time T equals 5. That's all you're doing. Now it says, using correct units, interpret your answer in the context of the problem. So what does this negative 24.588 mean? Okay, it means you would write something like the rate at which gravel is arriving is decreasing by 24.588 tons per hour squared at T equals 5 hours. Okay, the parts that are important, you have to put at what time, because that's from there. Put your answer in there somewhere. Put your units in there somewhere. And then what it is. What is a derivative of a rate? It's another rate. It's like an acceleration. So it's decreasing by that. Okay, that's part A. Let's look at part B. Find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. Okay, well, if it is arriving at a rate of G of T, the total amount is the derivative of that between 0 and 8. Again, this is pretty easy. Just put things in your calculator. You need to write this down so they know where the answer comes from. Oh, changed color on me. But all you're doing is putting that in your calculator. All right, you cannot just put the answer down. You have to show what you did in your calculator in order to get it, but you can use G of T. You don't have to write down that whole thing. What are the units of this? If the units of G of T are tons per hour, we're going backwards, taking a derivative. That means the hour goes away, so this is tons. Okay, there are 825.551 tons that arrives at the plant during the hours of operation. That's your answer. So I didn't tell you for the first part, for this one, for part A, you would have gotten 1 point for that answer and 1 point for this answer, for the interpretation. For this one, you would get 1 point for showing the integral and 1 point for your answer. Now let's look at part C. Is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5? Show the work that leads to your answer. Well, the amount, the rate at which it's coming in is G of T. The rate at which it's going out is 100. So we want to find, is G of 5 less than or greater than 100? That's what we need to find. Is it coming in faster than it's going out, or is it coming in slower than it's going out? So we're going to find G of 5. Okay, again, you're just putting that into your calculator and you get 98.140764. You obviously don't need to round it that much. And we're going to say that is less than 100. So at t equals 5 hours, the rate at which the gravel is arriving is less than the rate at which it is being processed. So the amount of gravel is decreasing at time equals 5 hours. Okay, since it's arriving at a less rate than it is being processed, the amount is decreasing. Make sense? All right, let's look at part D. Oh, and for that one, you would have gotten, let me go back. You would have gotten 1 point to compare G of T and 100 and 1 point for your answer right there. Now part D, what is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? Justify your answer. Okay, so to find the maximum amount of unprocessed gravel, we need to know what is the amount of unprocessed gravel at any time. So we're going to call A of T is the amount of gravel at any one time. All right, and that equals 500 because that's what we're starting with, plus the integral from 0 to t of G of x dx minus, well, I think I'll write it like this. So this is how G of x is how fast it's coming in, and 100 is how fast it's going out. So that is the answer that is how we would find the amount of gravel at any one time t. So we want to know when it is a maximum. So to find a maximum, you take a derivative. Well, the derivative, 500 is going to go away, and the derivative of this is just going to be g of t minus 100t. No, I did that wrong. It's just g of t minus 100. All right, so we are going to find, we want to know when it's a maximum. We're going to set this equal to 0, and we're going to get a t of 4.923 hours. Now, remember, when you're finding an absolute maximum, they're not just wanting a relative max between 0 and 8. We also have to check the 0 and the 8. And then this, well, at time t equals 0, we had 500. At time t equals 8, you would put an 8 into this, and you would do that on your calculator, and you should get 525.551. And if you put 4.923 into that equation on your calculator, you would get 635.376. So you would say the maximum amount of gravel is 635.376 tons at time equals that if you wanted, but it didn't ask you for that. It just asked you what the maximum was. So that is the answer to number 1. Let's look at number 2. A particle moving along a straight line between 0 and 5. The velocity is given by that, and the position is going to be s of t, and we know that s of 0 equals 10. So we've got velocity, and we have s of 0 equals 10. Find all values of t in the interval between 2 and 4 for which the speed of the particle is 2. All right, you need to know that speed equals the absolute value of v of t. So we want to find when is the absolute value of v of t equal to 2 between 2 and 4. That's what we're looking for. So you're going to take, you can actually put absolute value into your calculator. You should research that if you know how to do it. So you could do that. You could put absolute value of v of t. Well, it wouldn't be lines like that. You could put this in for v and take the absolute value of it and set it equal to 2 and see what you get. You should get, this is all the stuff on your calculator, t equals 3.128 or 127, and t equals 3.473. 2, there's 2 of them where it equals, the absolute value equals 2. That's your answer to part A. You get 1 point for knowing that speed equals absolute value, and that you have to set that equal to 2, and then you get 1 point for your answer. Part B, write an expression involving an integral that gives the position. Use this expression to find the position at time t equals 5. So the position of a particle is the integral of velocity, but we need to also put 10 there because that's where we're starting. And that's all you need. You get 1 point just for writing that. Okay, that to know that position equals the integral of velocity plus where you're starting. Then it says use this to find s of 5. So you're going to substitute in 5 there. and you're going to do this on your calculator, and you get negative 9.207. All right, you get 1 point for writing that expression, and you get 1 point for this answer. And now part C. Find all the times t in the interval between 0 and 5 at which the particle changes direction. When does the particle change direction? It's at a relative max or min is where it changes direction. So you need to find where v of t, which is the derivative of the position, equals 0. So you're going to put that in your calculator and find all the zeros in our interval from 0 to 5. And you're going to get t equals 0.536 and t equals 3.318. Okay, that's where it equals 0. But that doesn't tell us that it changes direction, because it could just stop and go in the same direction. So then you have to also show or state that v of t changes sign from negative to positive at t equals 0.536, and v of t changes from positive to negative at t equals 3.318. Therefore, the particle changes direction at both of those spots. So you get 1 point for setting it equal to 0 and 1 point for your conclusion. And we have one more for this. D, is the speed of the particle increasing or decreasing at time t equals 4? So the speed, we're going to find the velocity at time t equals 4, and that's negative 11.476, which is less than 0. And then we're going to find the acceleration at time t equals 4, which is the derivative of that number. And that equals negative 22. And that's less than 0. So since they are the same, the speed is increasing at time t equals 4, because velocity and the acceleration have the same sign. They're both negative. If they're both negative or if they're both positive, they are increasing. And if they are different signs, one's positive and one's negative, then it is decreasing. You get 2 points for that one. All right, let's look at the next one. Ooh, it's a table problem. Question number 3. Hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup is given by a differentiable function c, where t is measured in minutes. Selected values of c of t, measured in ounces, are given in the table. Use the data in the table to approximate c prime of 3.5. Okay, when it tells you to approximate something from a table and it's asking for a derivative, it's asking for you to use a slope for the approximation. So you're going to look up there and see where 3.5 falls between 3 and 4. So you're going to find the slope between the point 3, 11.2, and 4, 12.8. So you're going to say 12.8 minus 11.2 over 4 minus 3. And you're going to get 1.6 ounces per minute. Okay, these are ounces, these are minutes. So it's ounces per minute. So you need to write this down so that they can see. You can't just write this. Okay, you've got to put something in between that so they know where you got that 1.6 from. You can even put an extra part in here where you say C of 4 minus C of 3 over 4 minus 3. You could put just one of those if you want, or both of those. Okay, so for this one, you get one answer for your 1 point for your answer and 1 point for your units. That's an easy one. All right, so when it asks you to approximate something from a table, a derivative from a table, it's asking you to find a slope. Remember, derivatives are slopes, and when we have to approximate a derivative, we're going to use a slope. And then it tells you actually there to show the computations. All right, B, is there a time, t, between 2 and 4, at which c prime of t equals 2? Justify your answer. Well, let's look. At time t equals 2, c is 8.8. And at time t equals 4, c is 12.8. So we're going to say, well, we know that c is differentiable and it's continuous on the closed interval because it told us that up there. It told us it was differentiable, which means it's continuous. Remember that differentiability implies continuity, but continuity does not imply differentiability. So we know it's differentiable and continuous. So if we look at the slope between these, I did that wrong. We're going to get 12.8 minus 8.8 over 2, which equals 2. So therefore, by the mean value theorem, there is at least 1 t between 2 and 4 such that c prime of t equals 2. All right, that's what it asked you. And that is the mean value theorem. You need to somehow tell that you're using the mean value theorem. You get 1 point for doing this, and you get 1 point for your conclusion using the mean value theorem. Oops. Now let's look at C. Use a midpoint sum with 3 subintervals of equal length indicated by the data in the table to approximate the value of 1 over 6 integral 0 to 6 of c of t dt. All right, and then we're going to say what that means. So we're using a midpoint. We're using, all right, to the midpoint to approximate this, the midpoint sum to approximate this, and then we're going to multiply it by this 1/6. So I'm just going to stick the 1/6 out there. And then it says 3 subintervals. So we're going to go from 0 to 2, and then we're going to go to from 2 to 4, and then we're going to go from 4 to 6. Okay, because it tells you equal length indicated by the data in the table. This, when it asks you for a midpoint, it's going to do this so that there's one in the middle that you can use. So remember, for the midpoint, we're going to take the midpoint between 0 and 2, which is 5.3, and then the length of this interval, which is 2, because we're taking areas of rectangles. This is the height, and this is the length, or the width of the rectangle. And then the next one, the height is going to be halfway between 2 and 4, which is at 3. And that one is also 2. They're all going to be 2 because it told us equal length. And then we're going to take halfway between 4 and 6, which is at t equals 5. And that is 13.8. And we're going to add all of these up. Okay? So you need to somehow write this down. You can write these down. You could have written C of 1, C of 3, C of 5. If you just wanted to write that and not write the numbers down. Somehow you got to show where you're getting your numbers from. And then you're going to do this, and you're going to get 10.1. And what are the units of that? Well, this is the units are ounces. Okay, because we're finding kind of an integral of a rate. So so that gives us back to ounces. Now it says, explain this in the context of the problem. All right, well, this right here is the total amount of coffee in the cup. But because we divided by 1/6, that told us that we're finding an average value. So 10.1 ounces is the average amount of coffee in the cup over the interval 0 to 6. Okay, that's what it is. You get 1 point for that answer. No, you get 1 point for showing this part right here. You get 1 point for your answer, and you get 1 point for your interpretation. And now there's one more part, D. Let's see if I can squeeze it down here. It's pretty easy. The amount of coffee in the cup in ounces is modeled by B of T equals that. Using this model, find the rate at which the amount of coffee in the cup is changing when T equals 5. All it's asking you for is B prime of 5. All right, so go ahead and put that in your calculator. This actually looks like it may have not been a calculator problem, because in the answers, they found the derivative of that, but you're going to be able to use your calculator. And so you would get a point for that. And for this one, this is, well, it's 6.4 over e squared, but you could obviously, with your calculator, you could put that in a decimal. If you have your calculator, they're gonna let you put it in a decimal. All right, let's look at question number 4. The figure above or to the side shows the graph of f prime. Remember, look carefully what the graph is. Is it f or f prime? The derivative of the twice differentiable function of f on the enclosed interval 0 to 8. The horizontal lines at x equals 1, x equals 3, and x equals 5. Horizontal tangent lines, I'm sorry. So those are where it changes. Those are like relative max and mins. The areas of the regions between the graph are labeled in the figure. So it tells you what the area is under those curves. So, and we know that f of 8 equals 4. So find all the values of x in the open interval for which the function has a local minimum. All right, so where f has a local minimum, that's a relative. A local min when f prime equals 0 and changes sign. Okay, now, so you gotta look, we're not looking at where this graph has a local minimum, we're looking at where f has a local minimum. So the graph is the derivative. So where does f prime equal 0? From the graph, f prime equals 0 at x equals 1 and 1, 2, 3, 4, and 6. Do you see that? That is where f has equals, where f prime equals 0. Okay, wait, this is a local min. It changes sign from negative to positive. So now we have to look at these to see where it changes sign from negative to positive. At x equals 1, it doesn't change sign, so that's not it. At x equals 4, it changes from positive to negative, so that would be a max. So at x equals 6 is where it changes from negative to positive. So you would say something like x equals 6 is a local min because f prime of 6 equals 0 and f prime changes from negative to positive, or something like that. Okay, you get 1 point for that. Part B. Determine the absolute minimum value of f on the closed interval. Justify your answer. So the minimum, the absolute min, occurs at the endpoints, or it occurs at the relative mins. So if we made our little chart, it's either going to be at 0 or 8 or at 6. So we have to find f of 0, and we have to find f of 6, and we have to find f of 8. So f of 0 is going to be, so let me write this here. 0 to 8 of f prime equals f of 8 minus f of 0, right? That's the fundamental theorem of calculus. So f of 0, if we change this around, f of 0 equals f of 8 plus f prime. Is it plus? Oh, that would be minus. It would be minus f prime of, or the integral of f prime of x dx from 0 to 8. So f of 0, I'm going to move this over, is going to be f of 8, which they gave us was 4, plus the integral from 0 to, or minus the integral from 0 to 8 of f of x. So the integral there is just going to be all those areas added together, but the ones below the x-axis have to be subtracted. So I'm going to erase this up here so I have space. So the integral from 0 to 8 of f of x dx, f prime of x dx, equals, the first area is 2, and then there's an area of 6, then there's an area of 3 that's below the x-axis, and then there's an area of 7. So when you add those together, you get 3, 7, 10, 12. You get 12. All right. So f of 0 is 4 minus 12, which is negative 8. Then f of 8, we already know, is 4. They gave us that. So f of 6 is going to be the integral. Well, I'm going to do the same thing I did over here. And because we're looking for f of 6, and we know f of 8, they gave us that, we're going to look at the integral from 6 to 8 of f prime of x dx, and that equals f of 8 minus f of 6. That's the fundamental theorem of calculus. So f of 6 equals f of 6, rearranging this right here, f of 6 equals f of 8 minus the integral from 6 to 8 of f prime of x dx. So again, f of 8 is 4, and now we have to look at the integral from 6 to 8 of f prime of x dx. So looking at our graph, where is 6? 1, 2, 3, 4, 5, 6. 6 to 8 is just that last one. That's 7. So 4 minus 7 equals -3. So this is our little chart that tells us what the absolute minimum is, and it's going to occur either at 6, which is the local min or relative min, or the endpoints. So what is the absolute min? Absolute min is -8 at x equals 0. Okay, so you get, let's see, you get 1 point for using the endpoints. You get 1 point for your answer, and then you get 1 point for your justification, which all of this stuff would be. All right, let's look at part C. On what open intervals is the graph of f both concave down and increasing? Okay, so it's going to be concave down. I would write stuff like this down. Concave down when f double prime is less than 0, and increasing when f single prime is greater than 0. So remember, this graph is f single prime. So where is it greater than 0? That's the easy one. It's greater than 0 from 0 to 1, then 1, 2, 4, and then 6 to 8. Okay, that's where it's greater than 0. We don't go from 0 to 4. We take the 1 out because it equals 0 at 1. It's not greater than 0. Then where is the derivative of the derivative? Less than 0. It's when these slopes are negative. Okay, so when is the slope negative here? Well, from 0 to 1, if you drew a slope, it would be negative, and then it changes and it turns positive. The slope would turn positive because it's going up until you got to 1, 2, 3, until you got to x equals 3, and then it changes again to negative all the way to x equals 5, and then it changes positive again. So we have to see where these things overlap. Okay, we got 0, 1, 2, 3, 4, 5, 6, 7, 8. All right, it's concave down from 0 to 1 and 3 to 5. It is increasing from 0 to 1, 1 to 4, and 6 to 8. So where do they overlap? They overlap from 0 to 1, and oh, I should go like this, from here, and here, and here, and up here, it's here, and here. So where do they overlap? From 0 to 1 and 3 to 4. That's where they overlap. So that's where it is both concave down and increasing. Those two intervals right there. And then the last part here, D, it says the function g is defined by this. G of x equals f of x cubed. If f of 3 equals -5/2, find the slope of the line tangent to the graph of g at x equals 3. So to find the slope, we'll just have to find the derivative. So we need to find the derivative of g, which is going to be 3 times f of x squared times the derivative of what's inside. Okay, that's the chain rule. And we're looking at g of, g prime of 3, right? Yep. So it's going to be 3 times f of 3 squared times f prime of 3. Okay? Don't be afraid to write things out like this because it's going to be way easier. Because look, f of 3 is -5/2. And f prime of 3, you can find from your graph, 1, 2, 3, f prime of 3 is 4. So then you're just going to do this math right here, and you should get 75. Okay, you got 1 point for your answer, and you get 2 points for taking the derivative, like that. All right, that's the answer to that one. Number 5, we're going to skip because that's an area problem that I don't think is supposed to be on it. And let's do the very last one, a differential equation problem. dy over dx equals e to the y 3x squared minus 6x. All right, and then we have an initial solution or initial condition of it goes to the point 1, 0. Write an equation for the line tangent to the graph at the point 1, 0 and use it to approximate f of 1.2. All right, so to find an equation of a tangent line, we need a point and a slope. We have a point, which is 1, 0, and we need a slope. So we're going to take 1, 0 and put it in there to find our slope. So our slope is going to be e to the 0 times 3 times 1 squared minus 6 times 1. Okay, we're substituting 0 in for y, 1 in for x. And that equal e to 0 is 1, so this is 3 minus 6, we get negative 3. So our equation of our tangent line is y minus 0 equals negative 3 times x minus 1. Or y equals negative 3 x minus 1. I would leave it like that because it's going to be a lot easier to do the next part. We're going to use this to approximate f of 1.2 as approximately equal to negative 3 times 1.2 minus 1, which equals negative 3 times 0.2, which equals negative 0.6. Okay, that's a linear approximation. You get 1 point for finding this slope. You get 1 point for the tangent line, and you get 1 point for this approximation. Now let's look at part B. Part B, it says find y, the particular solution to the differential equation. So we have to actually separate the variables here and take derivatives. Okay, so what we're going to do, remember when you're solving differential equations, you put all the y's on the left and all the x's on the right. So this becomes 1 over e to the y dy equals 3x squared minus 6x dx. Okay, that is the separation of variables. Somehow you have to show that you separated the variables. Now we are going to take the integral of both sides. I'm going to rewrite this as e to the negative y dy. Whoops, I don't know why I put a parenthesis there. And over here, I can just go right ahead and take the integral. I get 3x cubed over 3 minus 6x squared over 2 plus c. All right, I'm going to write it like that because it's easier for me than trying to simplify it along the way. This, I'm going to take the integral of this. Now, I can't take the integral of this side until you can think of it as u substitution if you want. U equals negative y, du equals negative dy, so negative du equals dy. And then it would be the integral of e to the u du, which the integral of e to the u is e to the u negative, so it would be negative e to the negative y. Equals, now I can simplify this, x cubed minus 3x squared plus c. So I'm down to that. I have to solve for y. That's what we're doing here. We have to solve for y. At some point, I have to find c. So I think before I do anything else, I'm just going to, I think I'm going to substitute in my point. My point is 1, 0. I'm going to just substitute it in right here to find c. Negative e to the 0 equals 1 minus 3 plus c. because x is 1. Okay, so this side becomes -2 plus c, and e to the 0 is 1, so that becomes -1. So we get, whoops, we get c equals 1. So, oh no, I said I used too many. I'm going to erase some things up here. So now I have -e to the -y equals x cubed minus 3x squared plus 1. And I have to solve for y. I'm going to get rid of this negative, so I'm going to have e to the -y equals -x cubed plus 3x squared minus 1. Okay, and then I'm going to take ln of both sides, and I get -y equals ln of -x cubed plus 3x squared minus 1. So y equals -ln of -x cubed plus 3x squared minus 1. And that's my answer. So for this one, you would have gotten, there's a lot of answers, or a lot of points. You would have gotten 1 for the separation of variables. You would have gotten 2 for finding the integral of both sides, the antiderivatives. You would have gotten 1 for the c, constant of integration. You would have gotten 1 for putting in the initial condition, and then you would get 1 to solve for y. So look, even if you can't go through all of this to get down here, if you would have gotten up to this point right here, you would have gotten all the points except 1. So don't give up if you don't know how to go all the way to the end. All right, that's the end for this.